Okay, we have done all 4 conic sections now. So now is the hard part. And not too hard. You have to be able to recognize which one is which and know how to do what you're supposed to do with them. So the first thing we're going to do is just be able to pick out which equation represents which conic section. So let's review. We have circles, we have ellipses, we have hyperbolas, and we have parabolas. So I've kind of made it a little bit easy for you here for questions, for answers, so we can kind of use process of elimination. But we're also going to talk through each one. I think the easiest one to find is parabolas. How do we know parabolas when we see it? Parabolas, only one of the 2 variables is squared. So when I look at number 1, I have an x squared and a y squared. That's not it. When I look at number 2, I have a y squared, but I don't have an x squared. So I know right away that one is the parabola. Let's just double check through the rest of them. X squared, y squared, x squared, y squared. So that's how I pick out the parabola. Okay, now I have circles, ellipses, hyperbolas. We're going to go to circles next. In a circle, the x squared and the y squared have to have the same coefficient. So the x squared has to match the y squared. So here, those don't match. Here, those don't match. Here, they match. So this is my circle. Okay, so now I'm left with ellipses and hyperbolas. Let's do hyperbolas next. What does the equation of a hyperbola look like? It has a minus sign in it. So that's how we know the hyperbola when we see it. The x squared and the y squared, one of them has to be negative. So we go down and look. X squared's positive, y squared's negative. Aha, that's the hyperbola. Let's double check this one. The x squared is positive and the y squared is positive. So that is my ellipse. Because remember also back from the very beginning, ellipses and circles are very similar, except that circles, these two have to match. Ellipses, they can be different numbers. Okay? So let's go through that again. The order that I would recommend doing it. Parabolas first. And again, in a parabola, only one of them is squared. So only x squared or y squared, not both. Then I would jump to my circle. My x squared has to match my y squared. So they have to have the same coefficient. Then I would jump to my hyperbola and look for my minus sign. Either my x squared or my y squared has to have a minus sign. And then last but not least, I would do my ellipses, and they're both positive. Okay, so that's step number 1. We have to be able to figure out which one's which. Then we have to be able to get them in standard form. You've done all of these individually, but it's been a while since you've done some of them. So we're going to go through and just review how to do each one of these. So I'll start with the hyperbola just because it's on top. So I'm just going to rewrite the equation over here on my other paper. So give you some time to write it down also, because you're going to need some space to work with here. Okay, so there's my equation. And that's in that messy, general, ugly form that we don't like. So let's think about, what does a hyperbola equation look like? It looks like a fraction minus another fraction equals 1. We need the x's on top of one of them and y's on top of the other one. So we're going to mix our x's together and our y's together. So I'm going to go ahead and rewrite this so that I have the x squared and the x next to each other and the y squared and the y next to each other. And I'm going to get this number out of the way, so I'm going to move it over to the other side of the equal sign. And to move a negative 11 over here, I have to add 11. Why did I make the y second? Because that was my negative one. So that's the one that we want after the minus sign. So now remember, we complete the square, so we have to find the number to fit in both of those places. So this one, well, let's hold off for a second. First of all, I have to get my negative 4 out of the way here, right? So I have to pull that out, leaving me with y squared plus 4y. Because negative 16 divided by negative 4 is positive 4. Okay, so now I need to fill in both of my blanks. Remember, that's where I take half of this and square it. So half of 6 is 3. 3 squared is 9. Whatever I put over there, I got to put over there. Half of 4 is 2. 2 squared is 4. But I have to be careful because there's that negative 4 out front. So I actually haven't put a positive 4 here. I've actually put a negative 16. So negative 16 there. Go ahead and rewrite it with the squared. So that's x minus 3 squared minus 4 y plus 2 squared. Go ahead and combine these together. 20 minus 16 is 4. But again, in a hyperbola equation, it has to equal 1. So we need to get rid of this 4, so we divide by 4. But we have to divide everything by 4. For this first one, there's nothing to cancel, so it just stays x minus 3 quantity squared over 4. For the second one, the 4 and the 4, that reduces to 1. So we just have y plus 2 squared. You can leave it blank, but most people usually write the 1, because if they have to go to graph it, they need that number down there. And then 4 divided by 4 is 1. All right, so that's our hyperbola. Next, we're going to do our parabola, so rewrite your parabola equation from earlier. So we have 4y squared minus x minus 40y plus 107 equals 0. Let's remember what a parabola equation looks like. It has something over here that's not squared with a number in front. And then over here, it has a parenthesis that is squared. So we want to get our variable that's not squared to be by itself. Now, this is a little bit tricky. When you have an equation, it doesn't really matter what goes on what side, right? Because you can flip an equation around, it's still the same thing. We don't want this y squared to become negative because that will make life not fun. So what we're going to do is we're going to actually leave the squareds over here this time. We're going to move the x and the 107 over here. So x minus 107. Because to move it over there, we have to add x, subtract 107. All right. Our y squared term, in order to complete the square, has to be positive, or has to be a positive 1. So we need to get rid of that 4. So we're going to have to divide everything by 4. So we're going to divide this whole problem by 4. Wow, this is not going to be pretty. So we get y squared minus 10y equals 1/4 x.
Hunter Maston, please report to the front lobby. Hunter Maston, report to the front lobby.
Minus 107 over 4. So now we're going to go ahead and complete our square. Let's take half of that and square it. So that's 25. Then I have to add 25 over here. I'm going to blow some of your minds. We factor this. That's y minus 5 squared equals 1/4 x. We need to add 107 over 4 plus 25. In order to add fractions, you have to have common denominators. So we need to get a 4 under this 25. But whatever I do to the bottom, I have to do to the top. So this becomes 100 over 4. So negative 107 over 4 plus 100 over 4 equals negative 7 over 4. Last thing is we like a parenthesis here. So we're going to pull that 1/4 out in front. So 1/4 divided by 1/4 is 1. 7/4 divided by 1/4 is just 7. We won't normally give you one that ugly, just the way it happened to turn out based on that problem. Okay, let's review our ellipses and our circles. So for your ellipse, you have 9x squared plus 4y squared plus 162x plus 8y plus 732 equals 0. All right, so an ellipse, we are supposed to have a fraction plus another fraction equals 1. Actually, you know what? We are going to change. No, we'll leave it. All right, so here we go. So we want a fraction plus a fraction, so we want to put our x's together. 9x squared plus 162x. We want to put our y's together. 4y squared plus 8y. We want our 732 on the other side. Then our x squared and y squared have to be just positive 1 in front. So we're going to factor that out. So we get 9x squared plus, let's see, 9 into 16 is 1, 18x. You can use your calculator there if you need to. Pull the 4 out front. Y squared plus 2y. Now we're going to go ahead and work that out. So half of this squared is 81. Half of this squared is 1. But we have to remember to put them over here, but you have to remember that that's out front. So 81 times 9 is 729. 1 times 4 is 4. So I get 9 parentheses, oh, let's go ahead and factor that while we're here. So we're going to make that x plus 9 squared plus 4y plus 1 squared. Add those two together, you get 733. 733 minus 732 is 1. Normally we would mess with this and get the numbers underneath and all that business, but since we don't need to go any further, we're just going to leave it there for today. All right, so that's our ellipse. All right, last but not least, we have our circle. So circle x squared minus 2x plus y squared minus 4y minus 25 equals 0. Let's remember what a circle looks like. Not a circle itself, but the equation. You have 1 parenthesis squared plus another parenthesis squared equals the radius squared. So we want to keep our x's and y's over here. So I've got x squared minus 2x, and I need to complete the square, plus y squared minus 4y, and I need to complete the square. Move the 25 over there. Half of this squared is 1. Half of this squared is 4. There's no numbers out front of either of these parentheses, so I'm actually just adding a 1 and a 4. Write it in my squared form, so factor that, you get x minus 1 squared. Factor that, you get y minus 2 squared. 25 plus 1 plus 4 is 30. And there is your circle.